So a big part of algebra is making sense of data. And a lot of the data we see either falls into one of three categories. Either it's going to have a positive correlation, a negative correlation, or it's not going to have a correlation. Now, the way that we gather data, oftentimes we put it into a table, but then we can also represent it graphically. So this is just quick examples here, right? I might have a bunch of data that looks like it's kind of going up. All right, and that's what we call a positive correlation, because if more of something happens, the more of something else happens. You can see there's kind of a line that would have a positive slope. So we say that that has a positive correlation. All right, so then on the negative side, it's just going to be a bunch of points that kind of point downwards. Not always perfect, but generally it's going down, right? As more of something happens, the less of something happens. That's what we call a negative correlation. Now, if there's no correlation, it just seems to be a bunch of random points all over the place. There's not really any kind of a pattern. I couldn't say whether or not that's going up or down. So we would say that has no correlation. So if we look at some examples here, we can start off by looking at this table. Okay. So we have the table that shows the number of soft drinks sold at a small restaurant from 11 a.m. to 1 p.m. All right, so just to graph it real quick, at 11 a.m. they sell 20 soft drinks. At 11:30, that's 29, so just under 30. At 12 o'clock, it was 34. At 12:30, it was 49. And at 1 o'clock, it sold 44 drinks. Okay, so that's a scatter plot there. So we say that that has a positive, a negative, or no correlation. Well, we can see by looking at the graph, it has a positive correlation. As time goes on, as time increases, then the number of sodas they sell increases. So that we would say has a positive correlation. But then if we look at the table, we can also see that as time goes on, the numbers are increasing, right? So as these here are increasing, these here are also increasing, right? This would be X and this would be Y. So as the time of day increases, the number of drinks is also increasing. So then we say it has a positive correlation. It's a positive correlation. So we look down at these examples here. This is some simple examples, but just to get you used to what data looks like in a graph and a table and what the relationship is. So down here this says the number of rainy days, and up here it says umbrellas sold during the month. So you just stop and think, well, if it's raining more days, will they sell more umbrellas? So that's why we have a positive correlation. So the more it rains, the more umbrellas that Walmart is going to sell. So that would be a positive correlation. All right. Then we look at this one here. It says the number of miles driven and the gallons of gas in the tank. Well, we know that the more you drive, the less gas you're going to have because you're using up gas as you drive. And we can see that since this is pointing downwards, it's going to be a negative correlation. All right. Okay, now if we look here at number 4, now we're just given the scenario. We don't have the graph. We just logically got to determine if there's a correlation or not. So number 4 says the temperature during the day and the number of people in the pool. Well, let's think about that. As the temperature rises, will more people go swimming? Usually people go swimming when it's hot. So if it's 90 degrees, there's going to be more people in the pool than if it's 60 degrees. So that then we would say is a positive correlation. As time increases, the number of people in the pool will also increase. As temperature increases, the number of people in the pool will also increase. Okay. Then the height of an algebra student and the number of phone calls they make in 1 week. Well, does my height have anything to do with how many phone calls I make? Probably not. So we're going to say no correlation. They're just not related. All right, then in number 6, the scatter plot at the right shows a relationship between the number of batteries needed and the number of toys. Now we have to make a prediction. It says predict how many batteries will be needed for 11 toys. So we look at this data in here, and we just want to draw a general line. It's called the line of best fit. It's called the line of best fit. It's the line that best represents the data that we have. And we try to get half of the points on one side of the line and half of the points on the other side. So I'm going to have a line that looks something like this. All right. So I just draw the line all the way up. So I can say, well, if I sell, 13, 14, 15 toys, I can figure out how many batteries are going to be needed based on what's on this line here. Okay, so the question is, how many batteries will be needed for 11 toys? Well, now that I have my line drawn, I just go to 11 toys, and I go up to see how many batteries that would be. So I'm on the line. It's a little less than 40 and more than 35, so let's call it 38 batteries. All right? So that's just a prediction, 38 batteries based on the line of best fit.